Tonight we're going to explore one of the most ambitious ideas humanity has ever imagined. Not a faster rocket, not a mission to Mars, not even a colony somewhere within our own solar system. Tonight we're going to follow a single starship as it leaves everything our species has ever known behind. Imagine a vessel so large that it carries forests beneath artificial skies. Imagine children being born inside its rotating habitats, growing old without ever standing beneath Earth's sun. Imagine generations living entire lives while the destination remains nothing more than a brighter point among countless stars. Somewhere beyond the fading glow of the planets, the engines finally fall silent. Ahead lies only darkness stretching across light years. Behind lies the home that slowly disappears until it becomes impossible to distinguish from every other distant star. But could such a journey truly survive? Could a machine built by human hands continue functioning for centuries, perhaps millennia, without docks, factories, spare parts, or rescue? More importantly, could the civilization living inside that machine survive long enough to reach another world? By the end of tonight, you will understand why this may be the greatest engineering challenge, the greatest biological challenge, and perhaps the greatest philosophical challenge our civilization will ever face. Before we begin, if you enjoy exploring questions that stretch from human history to the edge of the observable universe, consider joining us for more journeys like this. Now, let us begin. The history of exploration often begins with maps, coastlines, and unfamiliar horizons. Ancient sailors stood on wooden decks wondering whether the sea ended in monsters or opportunity. Centuries later, explorers crossed continents, believing that every mountain concealed another valley waiting to be discovered. Each generation imagined it had reached the edge of possibility, only to discover that the horizon simply moved farther away. Yet every previous journey shared one comforting certainty. Somewhere behind every expedition was home. A damaged ship might return to port. A caravan could retrace its path. Even the earliest astronauts orbiting Earth could look through a window and see an entire planet filling half the sky, close enough to remind them that rescue remained conceivable. A true interstellar voyage erases that reassurance completely. Once the engines commit to the journey, there is no turning around in any practical sense. Distance expands with relentless patience until every radio transmission requires years simply to say hello. The familiar relationship between traveller and homeland quietly dissolves. Earth ceases to be a destination. It becomes history. Picture the moment from inside the ship rather than outside it. The departure itself is almost anticlimactic. There are no roaring crowds after the acceleration phase ends. No dramatic soundtrack accompanies the slow fading of the sun. The corridors remain softly illuminated. Air circulates through hidden ducts. Water flows through recycled plumbing. Somewhere, a child laughs without understanding that every human civilization ever built now lies behind a widening gulf of empty space. Daily life continues because it must. Breakfast is prepared. Engineers inspect machinery. Teachers explain mathematics to students who have never experienced rain falling under a natural sky. Farmers tend carefully balanced ecosystems illuminated by artificial sunlight that follows schedules designed centuries earlier. Every ordinary routine quietly supports an extraordinary fact. Every heartbeat now depends upon a machine that cannot fail. That realization changes the meaning of the word spacecraft. The vehicles humanity has built so far are temporary shelters. Capsules carry astronauts for days, stations support crews for months. Even the most ambitious missions assume eventual return or regular resupply. A real starship cannot think that way. It is not transportation in the familiar sense. It is habitat, homeland, factory. Hospital, university, archive, government, ecosystem and memory combined into a single continuously operating structure. If a pump fails, there is no warehouse waiting in orbit. If knowledge disappears, there is no internet spanning interstellar space to recover it. Every tool, every skill, every scientific discipline must exist within the vessel itself. Survival becomes less about reaching another star than preserving an entire civilization inside an artificial world drifting through the cold between suns. For the first time in history, humanity would no longer be defined primarily by a planet. For hundreds of thousands of years, our identity has been shaped by oceans, continents, seasons, gravity, and a stable atmosphere. Every culture has grown beneath open skies. Every language has evolved while surrounded by natural landscapes. A generation ship quietly breaks that relationship. Its inhabitants may remember Earth through stories, recordings, and museums, but eventually every sensory experience comes from engineering rather than nature. Sunrise occurs because computers command enormous lighting systems. Rivers flow because pumps keep them moving. Forests survive because ecological balance is carefully maintained. Even weather becomes a designed phenomenon rather than an uncontrollable force. Civilization enters a remarkable transition. Nature is no longer something surrounding humanity. Nature becomes something humanity continuously rebuilds. This transformation raises an unexpected question. How long can an artificial world remain alive? Humanity already maintains machines that have survived for decades. Ancient mechanical clocks still measure time after hundreds of years. Cathedrals remain standing after nearly a millennium because generations repaired stone, replaced beams, and preserved knowledge. None of these achievements, however, survived alone. Every long-lived structure depended upon an equally long-lived civilization. Workers restored damage. Craftsmen passed skills from parent to child. Entire societies unconsciously became maintenance systems for the objects they inherited. A starship must accomplish something far stranger. The civilization maintaining it exists only because the ship itself continues functioning. Each depends entirely upon the other. The machine preserves humanity while humanity preserves the machine. Break either half of that partnership and both disappear together. Outside, the universe remains astonishingly indifferent. Interstellar space appears empty, yet it is anything but peaceful. Invisible particles race through the darkness at nearly the speed of light. Ancient radiation left over from the birth of the universe washes silently across every surface. Tiny grains of dust drift between stars with enough velocity to strike like microscopic bullets. Temperatures plunge toward the coldest conditions nature permits, interrupted only by the faint warmth radiating outward from the ship itself. There are no nearby planets offering shelter. No magnetic field spreads across millions of kilometers as Earth's does. No atmosphere burns away dangerous debris before impact. Every layer of protection must travel with the vessel from the beginning, because there will be nowhere else to find it. Perhaps the greatest illusion surrounding interstellar travel is that propulsion represents the central obstacle. Powerful engines capture imagination because they are dramatic. We picture brilliant exhaust plumes, immense reactors, or sails pushed by distant lasers. Yet once the journey truly begins, propulsion becomes strangely unimportant. Engines may operate for years before shutting down forever. The remaining centuries belong to quieter systems, air recyclers, water purification networks, agricultural habitats, medical knowledge, social stability, education, governance, memory. The story of a surviving starship is ultimately not the story of acceleration. It is the story of endurance. And endurance has always demanded something different from invention. Building a remarkable machine is difficult. Preserving that machine across generations is often harder. Human history repeatedly demonstrates this truth. Empires capable of astonishing engineering eventually lost techniques they once considered ordinary. Libraries vanished. Languages disappeared. Entire technologies faded because the societies supporting them collapsed. A starship cannot afford such forgetting. Knowledge itself becomes a life support system. Every generation inherits not only machinery, but responsibility. Children born beneath artificial skies must become guardians of decisions made centuries before their birth. They will maintain systems whose original designers have been dead longer than recorded history. They may never meet anyone who actually remembers Earth firsthand. Yet their survival depends upon remaining faithful to principles established before their ancestors even left home. The deeper we follow this imagined voyage, the more the original question begins to change. At first, it seems straightforward. How long could a real starship survive in deep space? But perhaps that is not the right question at all. Steel does not decide to continue. Computers possess no dreams of reaching another sun. Machines endure only because civilizations choose to maintain them. The true question may be whether human purpose itself can survive across interstellar distances, across centuries of isolation, across generations that inherit a destination they never chose. And before we can answer that, another challenge quietly emerges from the darkness. Just how far away are the stars we hope to reach, and what does that distance truly mean? The first question seems simple. Could a starship survive in deep space? But almost immediately another question begins to overshadow it. Survive for how long? A year? A century? 1,000 years? The answer depends on something that is difficult for the human mind to grasp, because our instincts evolved for journeys measured in days and landscapes measured in kilometers. Interstellar travel is measured in light. Before we can understand how long a starship might endure, we must first understand the extraordinary scale of the ocean it hopes to cross. Stand on the observation deck as the engines complete their final acceleration. Behind the ship, the sun is no longer the brilliant center of the sky. It has become one star among many. The familiar constellations have begun to change almost imperceptibly as perspective shifts across the galaxy. Ahead lies only darkness interrupted by distant points of light, each one another sun, each separated from the next by distances so immense that ordinary language begins to lose its usefulness. Space does not feel crowded. It feels almost infinitely empty. The nearest star system beyond our own is approximately 4.2 light-years away. That number sounds surprisingly small until it is translated into something more familiar. A light-year is not a measure of time, but of distance. It represents how far light, the fastest thing known in nature, travels in 1 year. Even moving at nearly 300,000 kilometers every second, light still requires more than 4 years to reach our nearest stellar neighbor. Every spacecraft humanity has ever launched moves only a tiny fraction of that speed. Imagine driving a car without stopping. Imagine flying continuously without ever landing. Imagine crossing every ocean on Earth thousands of times. None of these comparisons come close. The distances between stars are so large that planets become insignificant details within them. If our solar system were reduced to the size of a coin, the next nearest star would still be hundreds of kilometers away. Most of the journey is not spent approaching another civilization. It is spent traveling through almost unimaginable emptiness. That emptiness changes everything. Throughout history, explorers relied upon places between destinations. Islands provided fresh water. Ports offered repairs. Towns became centers of trade and recovery. Even modern aircraft cross skies filled with airports below. Deep space offers no equivalent. Between stars there are no convenient harbors waiting for travelers. A damaged vessel cannot simply stop for maintenance. Every repair must come from resources already carried aboard. Every mistake becomes permanent unless the ship itself possesses the ability to recover. This realization quietly transforms the mission. The destination remains important, but the journey itself becomes the true challenge. If the voyage lasts centuries, then the ship is no longer merely crossing space. It is creating a new environment in which human history continues to unfold. Birthdays are celebrated. New scientific discoveries are made. Languages slowly evolve. Traditions emerge that no one on Earth could have predicted. The voyage becomes long enough for history to occur inside the vessel. Human civilization has rarely built anything expected to operate continuously for centuries. Some cathedrals have stood for nearly 1,000 years, but they endured because countless generations repaired them. Ancient bridges survived because stones were replaced before failure spread. Even forests remain healthy only because nature constantly renews them. Longevity has never been the result of permanence. It has always depended upon continuous renewal. A starship must follow the same principle, but under conditions far more demanding than anything humanity has previously attempted. Outside the hull, the galaxy continues its own slow rhythm. Stars orbit the center of the Milky Way over hundreds of millions of years. Clouds of gas drift between spiral arms. Invisible gravitational forces quietly shape the architecture of the galaxy. Against this immense backdrop, one tiny vessel moves almost unnoticed. Yet inside that vessel, every hour matters. Air must remain breathable. Water must remain pure. Crops must continue growing. Thousands of small successes accumulate into another day of survival. The contrast is remarkable. On the cosmic scale, centuries are insignificant. Entire civilizations can rise and disappear in less time than the galaxy completes a fraction of its orbit. For the people aboard the ship, however, a single failed valve or contaminated water supply could determine whether future generations ever exist. Vast astronomical distances ultimately depend upon the reliability of ordinary engineering. As the years become decades, another unexpected consequence appears. Communication with Earth begins to stretch beyond ordinary conversation. A message sent home takes years to arrive. The reply requires years more. Eventually, an entire childhood may pass between one question and its answer. News becomes history before it is received. Political systems may change. Scientific revolutions may occur. Entire generations on Earth may live and die while the travelers wait for a single exchange of information. Slowly, the emotional connection between the ship and its birthplace begins to change. Earth remains important, but it no longer feels immediate. It becomes a place known through archives rather than experience. The youngest members of the crew understand it the way modern people understand ancient civilizations, vividly described, carefully preserved, but personally unreachable. Their home is no longer a planet. Their home is the ship itself. And that realization introduces an even deeper challenge. Distance is not merely measured in kilometers or light years. It is measured in separation from everything that once made civilization possible. Every additional year widens that separation. Every generation born aboard the vessel inherits a world increasingly independent from the one that launched it. The Starship is no longer carrying explorers away from Earth. It is slowly becoming a civilization of its own. But if the voyage may last for centuries, another question can no longer be ignored. Even if people remain determined, can the ship itself continue functioning for that long? Or will time become a more dangerous enemy than the distance between the stars? Distance, remarkable as it is, turns out not to be the greatest obstacle facing an interstellar starship. Distance is simply a number. Time is what gives that number consequences. Every additional year in deep space allows countless small failures to accumulate. A seal hardens almost imperceptibly. A microscopic crack grows through repeated cycles of stress. A computer component experiences one more burst of radiation. None of these events matters on a voyage lasting months. On a journey lasting centuries, they become the quiet forces that determine whether an entire civilization survives. Imagine walking through the engineering decks 100 years after departure. The corridors remain clean. The air is comfortable. The artificial lighting still follows the rhythm of a 24-hour day. At first glance, everything appears almost unchanged from the day the ship left Earth. Yet beneath the polished surfaces, thousands of repairs have already taken place. Pumps have been rebuilt, structural panels have been replaced, sensors have failed and been recalibrated. Entire sections of machinery have quietly reached the end of their intended lives. The ship is no longer the machine its builders launched. It has become a machine continuously rebuilt by the people living inside it. This idea may seem unusual, but humanity has encountered it before. Consider an ancient city that has existed for centuries. Streets are repaved, roofs are replaced, walls are rebuilt after storms and earthquakes. Generation after generation contributes to its survival until almost none of the original material remains. Yet people still consider it the same city. Identity survives even as individual parts change. A successful starship may follow the same pattern. Its survival will not depend on preserving every original component. It will depend on preserving the ability to replace them. That ability introduces an entirely new level of complexity. Every spare part occupies valuable mass. Every kilogram carried across interstellar distances requires energy to accelerate. Bringing replacement components for every possible failure would make the ship impossibly large. Instead, the vessel must manufacture many of its own parts. Metal must be melted and reshaped. Electronic systems must be rebuilt. Precision tools must themselves be maintained so they can continue producing other tools. Maintenance evolves into an entire industrial ecosystem operating far from any planet. Even that may not be enough. Machines rarely fail one at a time. Complex systems often experience cascading problems. A cooling pump stops functioning, causing temperatures to rise. Higher temperatures reduce the lifespan of nearby electronics. Those electronics begin producing inaccurate data, delaying repairs. Small failures combine until they threaten systems that once appeared completely unrelated. Engineers refer to these events as cascading failures, but inside a generation ship they become something much larger. They become threats to an entire civilization. Nature offers surprisingly few examples of perfect reliability. The human body constantly repairs damaged cells. Forests recover after fires. Coral reefs slowly rebuild themselves after storms. Life survives because renewal is continuous rather than occasional. A starship designed for centuries of travel must imitate this principle. Instead of asking how to build a machine that never breaks, its designers must ask how to build one that never stops healing. Outside the hull, another relentless process continues. Interstellar space is far from empty. Tiny grains of dust drift silently between the stars. Most are smaller than grains of sand, yet the ship is moving so quickly that even microscopic particles carry extraordinary energy upon impact. Over decades, millions of these collisions gradually erode exposed surfaces. Protective shielding wears thinner. Optical instruments become less precise. Exterior structures slowly accumulate invisible scars. Radiation presents an even quieter danger. Unlike dramatic scenes in science fiction, radiation rarely announces its arrival. It passes silently through materials, occasionally disrupting atoms or damaging delicate electronic circuits. Modern spacecraft already experience these effects during relatively short missions. Engineers design systems with redundancy because they know that individual components will eventually fail. Extend that exposure across centuries, however, and the challenge changes dramatically. Redundancy alone may no longer be sufficient. Every backup eventually ages as well. This is one of the most important lessons in long-duration engineering. Nothing lasts forever simply because it was built well. Longevity comes from adaptation. Every successful system must expect failure, prepare for it, and recover from it repeatedly. The objective is no longer perfection, it is resilience. Resilience also changes the role of the crew. The people aboard are no longer passengers. Every generation becomes part engineer, part scientist, part historian. They inherit technical manuals written by individuals who lived centuries before them. They preserve manufacturing techniques that may never again exist anywhere else in the galaxy. Education becomes more than personal opportunity. It becomes a survival system. Losing essential knowledge could be as dangerous as losing oxygen. As decades turn into centuries, another subtle transformation occurs. Original design assumptions begin to lose relevance. The engineers who built the ship could not predict every circumstance their descendants would face. unexpected failures require creative solutions. New technologies may be invented aboard the vessel itself. Entire sections of the ship may be redesigned by people born long after launch. Gradually, the Starship evolves beyond its original blueprint. This evolution carries profound consequences. The mission no longer belongs solely to its founders, it belongs to generations that reinterpret it, improve it, and perhaps even question it. The vessel becomes less like a manufactured object and more like a living city continuously shaped by the people who depend upon it. Yet one unsettling question remains. Even if every machine can be repaired and every structure renewed, all of those efforts ultimately serve one purpose. They exist to keep human beings alive, and humans bring challenges that no engineering manual can completely solve. Air and water may be recycled, metal can be reforged, computers can be rebuilt, but can an entire biological world remain healthy inside a closed environment for centuries without slowly drifting toward collapse? If the ship can repair its machinery, perhaps the greatest challenge has been solved. At least that is what many early designers believed. Build reliable engines, carry manufacturing equipment, replace worn components as they fail. On paper, the problem appeared manageable. But a starship is not simply a machine wrapped around human passengers. It is an entire living world. The moment people step aboard, biology becomes just as important as engineering. And biology follows very different rules. Imagine entering one of the agricultural habitats 200 years after launch. Warm artificial sunlight filters through rows of fruit trees. Water flows quietly along narrow channels before disappearing into underground filtration systems. Bees drift from flower to flower beneath a ceiling that has never seen the real sky. Birds perch among branches that exist because generations of gardeners carefully protected them. The air smells faintly of soil and growing plants. It feels almost like Earth. Almost. Every breath taken inside the ship has already been breathed before. Every drop of water has passed through countless living organisms. The food served at every meal comes from the same enclosed ecosystem that has sustained the voyage since its beginning. Nothing is wasted because nothing can be wasted. Unlike Earth, there are no rivers flowing in from distant mountains. There are no oceans to dilute pollution. Every resource exists in a continuous cycle and every imbalance remains trapped within the system. Earth itself operates as a vast recycling machine. Forests absorb carbon dioxide while releasing oxygen. Oceans regulate temperature across continents. Billions of microorganisms hidden beneath the soil quietly break down waste and return nutrients to the environment. These processes seem effortless only because they occur across an entire planet. Compressing that complexity into a single spacecraft is one of the most demanding engineering challenges ever imagined. Early space missions relied on stored supplies. Water travelled inside tanks. Oxygen came from pressurized containers. Food arrived neatly packaged from Earth. These methods worked because astronauts returned home before supplies were exhausted. A journey lasting centuries makes such an approach impossible. Every kilogram launched from Earth eventually runs out. The only sustainable solution is to create an ecosystem capable of renewing itself indefinitely. That phrase sounds reassuring until one considers what ecosystems actually are. They are not static machines. They are living networks of extraordinary complexity. Remove one insect species and certain flowers fail to reproduce. Lose those flowers and another animal loses its food source. Change the chemistry of the water by a small amount and microscopic organisms multiply in unexpected ways. Nature rarely responds in straight lines. It reacts through countless invisible connections. The crew quickly learns that farming in deep space is unlike farming anywhere on Earth. A failed harvest is not merely an economic setback. It threatens every person aboard. Plant diseases spread through enclosed environments with alarming efficiency. Invasive fungi, harmful bacteria, or genetic weaknesses cannot simply be left behind in an abandoned field. Every square meter of cultivated land is essential. Agriculture becomes one of the ship's most advanced sciences rather than one of its oldest professions. Water presents an equally remarkable challenge. On Earth, people rarely think about where clean water originates. Rivers, lakes, glaciers, and rainfall quietly replenish supplies across the planet. Inside the ship, every glass of water depends upon continuous purification, human waste, plant material, humidity from the air, and countless industrial processes all become part of the same recycling network. The system cannot merely clean water. It must do so with extraordinary consistency for generation after generation without gradual decline. Air follows a similar cycle. Every breath removes oxygen and adds carbon dioxide. Plants reverse that process, but only if they remain healthy. Temperature, humidity, light intensity, and nutrient balance all influence their ability to perform this task. The atmosphere inside the vessel becomes less like empty space surrounding people and more like another living organ requiring constant care. Then there is the question of genetics. A voyage lasting centuries cannot rely upon a single generation of travellers. Children will be born, families will grow, future generations may never know anyone who once lived on Earth. Maintaining a healthy population requires careful planning not simply in terms of numbers, but also biological diversity. Too small a population risks reducing genetic variation over time. Too large a population consumes resources faster than the ecosystem can replenish them. Every birth becomes part of a carefully balanced equation linking biology to engineering. Disease acquires a different meaning as well. A common illness on Earth can often be isolated while hospitals receive outside assistance. A Starship possesses no neighbouring cities, no emergency supply flights, and no external medical infrastructure. Every outbreak must be contained entirely within the vessel. Medical research continues not because discovery is desirable, but because adaptation is necessary. Microorganisms evolve. Human immune systems change. Medicine itself becomes another life support system. Perhaps the most surprising realization is that the ship does not simply carry life, it carries evolution. Plants adapt to artificial lighting. Microbes adjust to enclosed environments. Human physiology slowly responds to generations spent away from Earth's gravity and atmosphere. Even if the designers create a perfectly balanced ecosystem at launch, the balance cannot remain perfectly unchanged forever. Life constantly changes because that is what life does. This transforms the mission once again. The objective is no longer preserving a frozen snapshot of Earth biology. Instead, the challenge becomes guiding a living world through centuries of gradual transformation without allowing those changes to become catastrophic. The crew are no longer merely caretakers of machines. They become caretakers of evolution itself. For a time, this seems like the deepest challenge imaginable. Keep the ecosystem healthy, and the voyage may continue indefinitely. Yet another question quietly emerges from beneath the success of biology. Even if food remains abundant, air remains breathable, and every child grows up healthy, what happens inside the human mind after generations spent beneath artificial skies? The body may survive the stars, but will the human spirit survive the journey just as well? A generation after departure, the children still ask about Earth. They gather around classroom displays showing blue oceans, snow-covered mountains, deserts stretching toward distant horizons, and forests moving beneath the wind. Their teachers explain seasons, tides, thunderstorms, and sunsets over natural horizons. The images are beautiful, but they already feel slightly unreal. To these children, Earth is not a place of memory. It is a place of imagination. 3 generations later, something subtle has changed. The lessons remain the same. The archives remain complete. Every photograph has been preserved with extraordinary care. Yet the emotional connection has begun to weaken. The youngest members of the ship know Earth in the same way people on Earth know ancient kingdoms that vanished thousands of years ago. They study it with fascination. They respect its importance. but they cannot truly feel what it was like to stand beneath an open sky without a ceiling overhead. This is the moment when the greatest challenge begins to move away from engineering and biology. The question is no longer whether the ship can support human life. The question becomes whether human beings can continue believing in a destination they have never seen. Throughout history, exploration has always been powered by expectation. A sailor expected to reach another shore, a caravan expected to arrive at another city. Even explorers crossing unknown continents believed that someone somewhere would eventually benefit from their hardships. A journey lasting several centuries breaks that pattern completely. The founders know they will never arrive. Their children know they will never arrive. Even their grandchildren may never come close. For most people aboard the vessel, the destination is not a future event. It is an abstract promise made by ancestors they never met. That realization quietly transforms the psychology of the mission. Walk through the residential districts during the evening. Families gather for meals, children complete school assignments, musicians perform in small public halls, gardeners trim trees growing beneath carefully engineered sunlight. Life appears peaceful, comfortable even. From the outside, the Starship resembles a prosperous town, yet every person living there shares one unusual condition. No one can leave. Every road ends at an airlock. Every horizon curves back into another corridor. Every landscape has been designed by engineers. The stars remain forever beyond reach. Psychologists have long understood that physical isolation affects the human mind in surprising ways. Researchers living through Antarctic winters often describe time becoming strangely distorted. Astronauts aboard orbital stations sometimes report an intense longing for ordinary experiences they once ignored. Rain falling on their faces, birds flying overhead, the smell of fresh soil after a storm. These missions last months. A generation ship measures isolation in centuries. The difference is almost impossible to comprehend. The founders can still remember Earth. They carry emotional memories that anchor their identity. Future generations inherit only descriptions. Memory gradually becomes history, and history slowly becomes mythology. Eventually a child asks a perfectly reasonable question. How do we know Earth ever existed exactly as the archives describe? The question is unsettling not because it rejects evidence, but because it reflects normal human behavior. Every civilization reshapes its own past. Stories become simplified. Heroes become legends. Difficult truths fade while comforting narratives survive. Across thousands of years, even carefully preserved history changes as each generation interprets it differently. A starship isolated from every outside influence experiences this process alone. There are no neighbouring societies to compare records. No historians from distant countries offering alternative perspectives. No archaeological discoveries challenging accepted beliefs. The ship becomes its own complete historical universe. Education therefore assumes extraordinary importance. Schools are no longer simply places where children prepare for careers. They become institutions responsible for preserving civilization itself. Mathematics, engineering, medicine, biology, history, philosophy, and ethics all become forms of infrastructure every bit as essential as oxygen generators and water recycling systems. Forget how to repair an air filtration system and lives are endangered. Forget why the mission exists and something even more valuable may disappear. Purpose. Purpose has always been one of humanity's greatest survival tools. People willingly endure extraordinary hardship when they understand why that hardship exists. Throughout history, civilizations have crossed deserts, oceans, and mountain ranges because they believed their suffering served a larger goal. Remove that purpose and endurance becomes far more difficult. Imagine living aboard the ship 500 years after launch. Everything functions. Food remains plentiful. The ecosystem is healthy. Technology continues advancing. Children laugh in the parks. Artists create music that has never been heard on Earth. Scientists make discoveries unknown to the civilization that launched the mission. From one perspective, the voyage has been an overwhelming success. Then someone asks another dangerous question. If life aboard the ship is already prosperous, why continue travelling at all? Why risk landing on an unfamiliar world? Why abandon the only home anyone alive has ever known? For the first time, the destination itself comes into question. This possibility worried many of the earliest thinkers who imagined generation ships. They realized that future societies would possess the freedom to redefine the mission. A civilization born in deep space might conclude that remaining aboard the vessel is safer than settling an unknown planet. In that moment, the ship ceases to be transportation. It becomes humanity's permanent home. What began as an expedition quietly transforms into an entirely new branch of civilization. This raises profound questions about identity. Are the people aboard still citizens of Earth, or have they become something entirely different? Cultures evolve through language traditions, music architecture, and shared experience. After centuries of isolation, the descendants of the original crew may speak differently, celebrate different holidays, develop different political systems, and tell different stories about their origins. They would still be human, yet they might no longer think like the civilization that launched them. Perhaps this transformation is not a failure of the mission. Perhaps it is the mission's inevitable success, because survival has never meant remaining unchanged. Every civilization that endured across history adapted to new environments, new technologies, and new generations. A starship crossing interstellar space would simply continue that ancient pattern on a scale never before imagined. But adaptation brings another challenge. A society can survive only if its people continue trusting one another. Machines may sustain the body. Purpose may sustain the mind. Yet neither can prevent conflict. And history suggests that the greatest danger facing any civilization rarely comes from the environment around it. More often it comes from within. By the time the voyage enters its 6th century, the Starship has accomplished something no machine in human history has ever achieved. It has remained alive across generations. Children have become grandparents. Engineers have trained apprentices who later taught apprentices of their own. Entire neighborhoods have been renovated more than once. From the outside, the vessel appears to have defeated time itself. But appearances can be deceptive. History offers a quiet warning. The civilizations that endured the longest were not always the strongest. Many possessed impressive technology, abundant resources, and stable governments. Yet they eventually discovered that survival depended upon something far less predictable than engineering. It depended upon cooperation. A starship is often imagined as a triumph of technology. In reality, it may become the greatest social experiment humanity has ever attempted. Picture the Central Assembly Hall during an ordinary week. Representatives from every district gather beneath a vast circular ceiling designed to resemble the night sky of Earth. Farmers discuss water allocation. Engineers request additional manufacturing capacity. Medical researchers recommend new health protocols. Teachers argue for expanded educational programs. None of these conversations concerns propulsion or navigation. The ship has been travelling on the same trajectory for centuries. Instead, every discussion concerns the ordinary problems of governing a civilization. The remarkable truth is that these ordinary problems may ultimately determine whether the mission succeeds. Every community develops disagreements. Resources must be shared. Rules must be enforced. Conflicts must be resolved before they spread. On Earth, societies possess options that a generation ship does not. People can migrate to another city. Nations can trade with distant partners. Communities can draw upon vast natural resources beyond their borders. A starship has no outside world. Every disagreement remains inside the same enclosed environment. Every conflict involves people who will continue living together tomorrow, next year, and for generations afterward. Isolation magnifies every decision. Consider something as simple as population growth. If too many children are born during a short period, food production and housing may struggle to keep pace. If too few are born, essential skills may disappear as older experts retire without successors. Demographic balance becomes a matter of survival rather than economics. The same is true of energy. Even an advanced power system has limits. Expanding one industrial sector may require reducing another. Increasing agricultural lighting could leave fewer resources available for manufacturing. Every choice echoes throughout the ship because every system depends upon every other system. Economists sometimes describe Earth as an interconnected global civilization. A generation ship takes that interdependence to its absolute limit. There are no external markets, no imports, no exports. Every object has been produced, repaired, recycled, or repurposed somewhere within the vessel itself. Waste acquires an entirely different meaning. A discarded metal tool is not simply garbage. It is future construction material. Unused heat becomes valuable energy. Organic waste becomes fertilizer. Even carbon dioxide becomes an essential resource for growing crops. Nothing truly leaves the system. This circular economy is extraordinarily efficient, but it also creates fragility. A disruption affecting one industry inevitably reaches many others. If manufacturing slows, replacement parts become scarce. Without replacement parts, agricultural equipment becomes harder to maintain. Reduced harvests increase pressure on food reserves, which in turn influences public confidence in leadership. Small disturbances ripple outward like waves across still water. Political systems must therefore accomplish something history rarely demanded. They must remain stable, not merely across elections or decades, but across centuries. Constitutions written by the founding generation may eventually appear outdated to descendants living in circumstances their ancestors never imagined. Should future generations possess the authority to rewrite the mission, should they be obligated to honor decisions made hundreds of years before their birth? These questions have no simple answers. Every civilization inherits traditions from the past while adapting to the present. The challenge aboard a starship is that altering one tradition may influence every aspect of life. A seemingly minor legal reform could affect education, resource management, scientific research, or population planning decades later. The founders understood this dilemma. They could design engines, they could design ecosystems. Designing a society capable of governing itself peacefully for centuries proved far more difficult. Trust becomes one of the ship's most valuable resources. Trust that engineers report problems honestly. Trust that scientists share accurate data. Trust that leaders make decisions for the common good. Trust that each generation prepares the next as carefully as the previous one prepared them. Without trust, even perfect technology begins to fail. Imagine an engineer discovering microscopic damage within a structural support. Repairing it requires temporarily shutting down a manufacturing facility, reducing production for several months. If leaders fear public criticism, they might delay the repair. The delay saves resources today, but increases the likelihood of catastrophic failure years later. Civilizations often struggle with problems whose consequences unfold slowly. Interstellar travel magnifies this tendency enormously. Many decisions aboard the ship produce results that those making them will never personally experience. The people planting orchards know they may never taste fruit from the mature trees. Scientists developing improved recycling systems may be long gone before their designs become essential. Teachers educating children understand that their greatest contributions belong to generation yet unborn. The voyage demands an unusual form of responsibility. People must care deeply about a future they will never witness. In many ways, this mirrors humanity's experience on Earth. Ancient builders began cathedrals knowing completion would occur long after their deaths. Farmers planted forests whose shade would shelter strangers centuries later. Civilization has always depended upon acts of long-term faith. A generation ship simply extends that principle across interstellar distances. Yet history also reminds us that cooperation is fragile. Prosperous societies sometimes divide over surprisingly small disagreements. Misunderstandings grow into rivalries. Rivalries become competing identities. Over time, shared purpose can quietly dissolve into competing visions of the future. The greatest danger may not arrive as mechanical failure or ecological collapse. It may arrive as a simple question. What if different groups aboard the ship no longer agree on where humanity should go? The engines continue carrying the vessel toward another star. But for the first time, the people inside may no longer be travelling toward the same future. For centuries, the builders of the Starship assumed that the greatest threats would come from outside. Radiation, micrometeoroids, mechanical failure, the freezing darkness between the stars. These dangers were real, and the ship had been designed to confront them from the very beginning. What they could not fully predict was the quiet complexity of the world growing inside it. A civilization is not a collection of identical people moving toward a common destination. It is a living system of personalities, ambitions, disagreements, friendships, traditions, and dreams. The longer the voyage continues, the more that living system develops a character of its own. Walk through one of the residential districts 8 centuries after departure. The architecture still follows the broad principles established by the founding generation, yet countless details have changed. Homes have been remodeled to suit new tastes. Public squares display sculptures celebrating events that occurred entirely aboard the ship. Children play games whose rules originated generations after Earth disappeared from living memory. Music echoes through the corridors, blending melodies inherited from humanity's past with instruments invented during the voyage itself. Culture has continued evolving. It never stopped. This should not surprise us. Human culture has never remained fixed for very long. Languages change, customs evolve, holidays acquire new meanings. Entire civilizations transform themselves over surprisingly short periods of history. The descendants of medieval Europe would find today's world almost unimaginable. Likewise, the descendants of a generation ship may eventually view Earth as the distant beginning of their story, rather than its defining chapter. Some historians aboard the vessel begin noticing an unexpected trend. The oldest archives receive fewer visitors each decade, not because people reject them, because daily life demands attention elsewhere. Young engineers are more interested in improving life support systems than studying 20th century politics. Farmers care about crop genetics adapted to the ship's ecosystem, rather than agricultural practices once used on Earth. Physicians focus on diseases unique to their enclosed environment. Every generation naturally directs its attention toward the challenges immediately surrounding it. Memory does not disappear all at once. It fades gradually through changing priorities. Recognizing this, the ship's educators begin experimenting with new ways of preserving historical identity. Museums become immersive environments rather than collections of artifacts. Children experience simulated forests where changing weather follows Earth's natural seasons. Entire neighborhoods recreate cities that vanished centuries before the voyage began. Students learn history not simply by reading about it, but by temporarily living inside carefully reconstructed moments from humanity's past. The effort is remarkably successful, yet it raises another question. Is remembering Earth enough? Or must future generations also understand why their ancestors chose to leave it? That distinction proves surprisingly important. A civilization that remembers only its origins may eventually become nostalgic. A civilization that remembers its purpose may continue moving forward. Purpose therefore becomes something that must be renewed rather than merely inherited. Philosophers aboard the ship begin describing the mission as a conversation extending across centuries. Every generation receives a question from those who came before. Will you continue? Each generation answers through its own actions before passing the same question onward. This creates an unusual relationship with time. On Earth, political leaders often think in years. Businesses plan across decades. Even the most ambitious public projects rarely extend beyond a human lifetime. A generation ship requires thinking across centuries. The consequences of today's decisions belong primarily to people who do not yet exist. This perspective slowly influences every institution aboard. Education emphasizes stewardship alongside innovation. Engineering values maintainability as highly as performance. Architecture favors adaptability over permanence. Even art begins reflecting the passage of generations rather than individual achievement. Murals stretching hundreds of meters record the names of every crew born aboard since launch. Great concert halls preserve compositions spanning 5 centuries of musical evolution. public celebrations commemorate not battles or conquests, but milestones of survival. The millionth successful harvest, the 1,000th complete water recycling cycle, the first child born into a new century of the voyage. The civilization has begun measuring history differently, not by wars, not by kings, but by continuity. Then an unexpected discovery changes the conversation. Astronomers monitoring the stars ahead notice subtle improvements in their instruments. The destination, once almost indistinguishable from countless other points of light, has grown fractionally brighter. The difference is invisible to the naked eye, yet sensitive detectors confirm the measurement. After centuries of travel, the ship has made measurable progress. The announcement spreads throughout the vessel. For many citizens, it is the first physical evidence that the journey is not merely symbolic. The destination is becoming real. Children gather in observatories to glimpse the distant star through powerful telescopes. Teachers explain that what appears as little more than a brilliant point will one day become a sun filling the sky. Artists create paintings imagining landscapes no human has ever seen. Writers compose stories about the first footsteps on an alien world. Hope quietly returns, not because arrival is near, it is still generations away. Hope returns because the future has become visible, yet visibility creates expectations. Expectations create debate. If arrival is now measurable, preparations must begin. What kind of society should greet another star? Should the descendants preserve the customs of Earth, or should they embrace the entirely new civilization that has emerged during the voyage? The question divides philosophers, historians, and political leaders alike. Some argue that the mission has always been to carry humanity outward exactly as it left Earth. Others believe the voyage itself has transformed humanity into something new, and that denying this evolution would betray the very resilience that allowed the ship to survive. Neither side rejects the mission. They disagree about what the mission now means. The debate remains peaceful, for now, but it reveals something profound. The Starship has succeeded so completely that its greatest challenge is no longer survival. It is identity. And identity has shaped the rise and fall of civilizations throughout history more often than any shortage of resources ever has. As the distant star slowly grows brighter against the darkness, another realization emerges. Reaching another solar system may prove easier than deciding what kind of civilization should arrive there. The distant star now has a name that carries meaning beyond astronomy. For the first generation that left Earth, it was a destination marked on navigation charts. For their descendants, it has become something closer to a promise. Children draw it in classrooms, poets describe it in verses. Musicians compose symphonies inspired by a sun that no human has yet seen with the naked eye. The farther the ship travels from Earth, the more its future begins to replace its past. Yet promises alone cannot sustain a civilization forever. A question that once belonged only to philosophers gradually reaches every household aboard the vessel. Why are we still going? For centuries that question had an obvious answer. Because our ancestors chose this journey. Because another world awaits. Because humanity must one day live among the stars. But time changes the weight of every answer. Imagine a young engineer standing beneath one of the ship's great observation domes. She has lived her entire life aboard this artificial world. Her parents did the same, so did her grandparents. She has studied Earth's history with admiration, but she has never walked across a real mountain or watched clouds form over an ocean. Everything she understands about home exists within the rotating habitats surrounding her. To her, the ship is not temporary. It is civilization. This difference in perspective slowly reshapes public debate. The founding generation viewed the vessel as a bridge between two worlds. Their descendants increasingly see it as one world complete unto itself. The distinction may appear subtle, yet it changes nearly every discussion about the future. Urban planners begin asking whether parks should be expanded instead of preserving unused industrial space intended for future planetary settlement. Architects propose larger residential districts designed for permanent comfort rather than temporary efficiency. Artists celebrate the beauty of enclosed gardens beneath artificial skies instead of depicting imagined landscapes awaiting them among the stars. The ship is no longer preparing only for arrival. It is building a lasting identity. Historians recognize that humanity has experienced similar moments before. Ancient ports founded as temporary trading settlements gradually became thriving cities. Military outposts evolved into capitals of powerful kingdoms. Communities established for a single purpose often discovered entirely new reasons to exist. The generation ship follows the same pattern. Its original mission remains unchanged. Its society does not. Meanwhile, science continues revealing another remarkable truth. The ecosystem has matured beyond its designer's expectations. Species introduced centuries earlier have adapted to their unusual environment. Certain plants grow more efficiently beneath carefully tuned artificial sunlight. Microorganisms have evolved to recycle nutrients with greater precision. Even insects display subtle behavioral changes shaped by generations spent inside enclosed habitats. Life has not merely survived, it has adapted. Biologists begin speaking of the ship as a unique biosphere rather than a miniature copy of Earth. It possesses its own ecological history, its own evolutionary pathways, and its own balance between countless living organisms. For the first time, the crew realizes they are protecting something that exists nowhere else in the universe. The ship itself has become a living world. This realization strengthens an unexpected movement among younger generations. They argue that the vessel deserves preservation regardless of whether another habitable planet is eventually reached. Destroying or abandoning it after arrival would erase centuries of biological and cultural evolution. Future historians might view the ship as humanity's first true artificial ecosystem, every bit as significant as the first cities or the first ocean-crossing civilizations. Others disagree. They remind the public why the mission began. Earth remained vulnerable. Planets can suffer climate change, asteroid impacts, volcanic catastrophes, or events too rare to predict yet too dangerous to ignore. The founders believed humanity needed more than one home if civilization was to endure across cosmic timescales. Remaining forever aboard a single vessel simply recreates the same vulnerability on a smaller scale. One accident, one unforeseen failure, one irreversible mistake. Everything could still be lost. The debate grows increasingly thoughtful rather than confrontational. Neither side questioned humanity's future among the stars. Instead, they ask what form that future should take. Should civilization spread across many worlds, or could carefully designed habitats eventually become worlds in their own right? Engineers unexpectedly enter the discussion. After centuries of continuous maintenance, they report something remarkable. Many sections of the ship no longer resemble their original construction. Successive generations of improved manufacturing methods introduced stronger materials, redesigned support structures, and replaced outdated technologies. In some areas, almost nothing built by the founding generation remains, yet the ship still functions. Perhaps better than ever, the announcement reminds many citizens of an ancient philosophical puzzle. If every component of an object is gradually replaced, is it still the same object? The question once seemed abstract. Now it defines the civilization itself. Every original engineer has long since died. Every structural panel has eventually been renewed. Every institution has evolved. Every tradition has changed. Is this still the same mission? Or has humanity quietly created something entirely new while believing it was preserving the old? No scientific instrument can answer such questions. They belong to history, to philosophy, to civilization itself. As preparations continue for the distant future, another discovery quietly arrives from the observatories. The destination star is no longer the only object demanding attention. Powerful telescopes begin detecting faint signatures from the planets orbiting it. Tiny variations in reflected light hint at atmospheres, weather systems, and perhaps even oceans. The destination is slowly transforming from a point of light into an actual planetary system. For the first time, the crew can begin asking not merely whether they will arrive, they can begin asking what they might find when they do. And that question will force humanity to confront a challenge unlike any it has faced before. For centuries, the destination had existed as an idea. A single bright star suspended against the darkness, carrying every hope invested in the voyage. Now, as observation technology continues improving, that idea begins to acquire detail. Tiny fluctuations in light reveal planets circling their parent star. Careful analysis suggests the presence of atmospheres. One world appears to possess liquid water. Another seems wrapped in thick clouds unlike anything in the solar system. None of these distant places can yet be seen directly, yet they are becoming increasingly real. With each new observation, excitement spreads throughout the ship. But so does uncertainty. Finding another planetary system is not the same as finding another home. Imagine standing once again inside the main observatory. Children press their hands against the transparent viewing panels, while astronomers project enlarged images across enormous displays. A faint point of light is transformed by mathematics into orbital paths, estimates of planetary size, and simulations of distant climates. No one has visited these worlds, no probe has landed there. Every conclusion is built from fragments of light that began its journey years before reaching the ship. The universe is finally revealing something about its destination, yet it is revealing only enough to provoke even deeper questions. The first concerns habitability. Throughout human history, people often imagined that finding another Earth would solve every problem. If another blue world existed, surely humanity could simply settle there and begin again. Reality is rarely so generous. A planet may possess oceans, yet have an atmosphere impossible to breathe. It may have comfortable temperatures but crushing gravity. Its soil may contain unfamiliar chemistry unsuitable for Earth plants. Its seasons may last decades instead of months. Even a world that appears inviting from a distance may become profoundly hostile upon closer inspection. The crew gradually realizes that reaching another star is only half the journey. Learning to live there may prove equally difficult. Scientists begin constructing increasingly sophisticated virtual models. They simulate weather patterns based upon faint changes in reflected light. They estimate atmospheric pressure using subtle spectral signatures. They debate whether rivers, glaciers, or vast inland seas might exist beyond the limits of observation. Every new discovery inspires another unanswered question. This pattern feels strangely familiar. Centuries earlier, explorers on Earth often filled incomplete maps with imagination. Coastlines were guessed before they were measured. Mountains appeared where none existed. Entire continents were believed to contain civilizations that later proved mythical. The astronomers aboard the ship are determined not to repeat those mistakes. Patience becomes their greatest scientific discipline. Meanwhile, another conversation begins unfolding elsewhere aboard the vessel. Engineers ask an unexpected question. What if the destination is unsuitable? The silence that follows is telling. For generations, the mission has assumed that arrival and settlement are inseparable. But astronomy offers no guarantees. The first accessible planetary system may simply not provide the conditions needed for long-term human survival. If that happens, what then? Continue onward to another star? Remain permanently aboard the ship? Attempt to transform an inhospitable planet over centuries? Each possibility carries consequences extending far beyond engineering. Children studying history now encounter a remarkable comparison. Early ocean explorers often reached islands that looked promising from the sea but proved difficult places to establish permanent settlements. Fresh water was scarce. Soil was poor. Storms arrived with relentless regularity. Some expeditions adapted successfully. Others abandoned their colonies after years of struggle. Interstellar settlement would magnify that uncertainty beyond anything humanity has previously experienced. There are no nearby continents waiting over the horizon. Every decision is final. The realization changes how people think about the ship itself. For centuries it was viewed as transportation. Now it begins to resemble insurance. If the destination disappoints, the vessel remains humanity's only guaranteed refuge. Architects therefore continue expanding its capabilities instead of allowing them to decline in anticipation of planetary settlement. Manufacturing facilities receive major upgrades. Agricultural districts become more productive. Scientific laboratories grow larger rather than smaller. Preparation for arrival unexpectedly strengthens preparation for remaining. The two goals no longer compete. They reinforce one another. Philosophers notice another subtle transformation. Earlier generations believed survival depended upon reaching another world. The current generation increasingly believes survival depends upon remaining adaptable enough to accept whatever reality awaits them. Hope shifts away from certainty toward resilience. This may be one of the voyage's greatest lessons. Human civilization has often mistaken plans for guarantees, yet history repeatedly demonstrates that successful societies are not those that predict the future perfectly. They are those that respond wisely when the future unfolds differently than expected. The ship itself stands as evidence. Its designers could never have anticipated every technological advance, every cultural change, or every biological adaptation that occurred during the journey. The mission endured because each generation learned to solve problems its predecessors had never imagined. Perhaps another unfamiliar planet represents simply the next chapter in that tradition. Still, one question lingers above every scientific discussion. Suppose the crew discovers unmistakable evidence that life already exists there. Not intelligent civilizations, not vast alien cities, only simple living organisms, tiny cells floating through ancient oceans, forests unlike any found on Earth, microbial ecosystems quietly evolving beneath distant skies. Would humanity possess the right to settle such a world? Or would preserving another independent branch of life become a responsibility greater than the mission itself? For the first time since departure, the greatest uncertainty no longer lies inside the ship. It waits at the end of the journey, and whatever answer humanity eventually chooses will define not merely how far our civilization has travelled, but who we have become along the way. The possibility of another living world changes the mission in ways no engineer could have anticipated. For centuries, the greatest uncertainty had been whether the ship could survive long enough to reach another star. Now a different uncertainty begins to eclipse it. If humanity succeeds, what responsibilities accompany that success? The debate begins quietly. Biologists argue that even the simplest extraterrestrial organism would represent one of the greatest scientific discoveries in history. A single microscopic cell that evolved independently from life on Earth would prove that biology is not unique to one planet. It would suggest that the universe may be far richer with living worlds than humanity ever imagined. Engineers listen respectfully before asking a practical question. If such life exists, where should people build their first settlement? Every valley, every shoreline, every underground reservoir could already belong to an ecosystem billions of years in the making. Establishing farms, constructing cities, and extracting minerals might permanently alter processes that had unfolded undisturbed since long before human civilization existed. For the first time, arrival itself appears capable of becoming an act of destruction. Inside the ship's universities, students study another chapter from Earth's history. Again and again, civilizations believed they had discovered empty lands, only to learn later that those places possessed histories of their own. Forests once considered endless disappeared within generations. Rivers changed course beneath expanding cities. Entire species vanished before anyone understood their ecological importance. The lesson is uncomfortable. Humanity is often confused unexplored with uninhabited. Astronomers therefore become increasingly cautious in interpreting every new observation. Spectral data is examined repeatedly. Atmospheric chemistry is modelled from multiple perspectives. Every possible explanation is tested before conclusions are accepted. The closer the ship comes to its destination, the more patient its science becomes. Meanwhile, another realization begins spreading through the engineering community. The ship itself has become an extraordinary scientific instrument. Its observatories have been upgraded hundreds of times since launch. Each generation improved optical systems, computational methods, and detection technology. The descendants of the original crew now possess capabilities their ancestors could scarcely imagine. Ironically, the voyage designed to reach another world has also transformed humanity into better observers of the universe. Distance has become a teacher. Centuries of uninterrupted astronomical observation reveal subtle changes impossible to detect during short-lived missions. Variable stars complete cycles recorded across generations. Interstellar dust clouds drift almost imperceptibly against distant galaxies. Planetary atmospheres reveal seasonal variations measured over hundreds of years. The crew realizes they have accumulated one of the longest continuous scientific records in human history. Knowledge itself has become one of the mission's greatest achievements, yet knowledge rarely simplifies difficult decisions. If another planet contains no life settlement appears morally straightforward. If it hosts intelligent life, the answer seems equally clear. Humanity would almost certainly avoid interference. But between those two extremes lies a far more complicated possibility. A living world inhabited only by simple organisms, too primitive to communicate, too important to ignore. Some philosophers argue that humanity's highest responsibility is ensuring the survival of its own civilization. Others suggest that preserving an entirely separate origin of life may represent an even greater obligation. The discussion reaches nearly every household aboard the vessel. Parents ask what kind of future their children deserve. Teachers ask what values should guide the first explorers. Religious traditions develop new interpretations of humanity's place within creation. Scientists remind everyone how little is actually known. No vote is taken. No final answer emerges. Instead, something unexpected happens. The civilization grows comfortable living with uncertainty. Earlier generations sought certainty before making decisions. Centuries of interstellar travel have taught their descendants another approach. Gather better evidence, improve understanding, delay irreversible choices until knowledge justifies action. Patience becomes a cultural virtue. That patience soon proves valuable for another reason. As observational data continues improving, researchers notice that the destination system is far more dynamic than originally believed. Solar activity fluctuates dramatically. One planet experiences unusually powerful magnetic storms. Another appears to possess unstable climatic cycles lasting decades. The destination is becoming more detailed. It is also becoming more complicated. No simulation perfectly matches reality. Every answer uncovers another layer of complexity. Looking back across the voyage, the pattern becomes unmistakable. Distance was never the only obstacle. Time revealed challenges hidden behind distance. Biology revealed challenges hidden behind time. Society revealed challenges hidden behind biology. Now, ethics reveals challenges hidden behind success itself. The Starship has not merely crossed interstellar space. It has climbed steadily through deeper levels of understanding about what civilization actually requires. Technology alone proved insufficient. Engineering required biology. Biology required cooperation. Cooperation required shared purpose. And shared purpose now requires wisdom. Yet even as these profound questions occupy the minds of philosophers and scientists, another realization quietly emerges from the historical archives. None of these ideas are entirely new. Long before the first-generation ship was imagined in detail, remarkable individuals on Earth had already begun asking whether humanity could someday become an interstellar civilization. Some lived more than a century before the voyage ever began. Some never saw a rocket leave the atmosphere. Yet their ideas laid the intellectual foundations for everything the crew now takes for granted. To understand how this impossible journey became imaginable at all, the story must briefly return to the people who first dared to think beyond the boundaries of Earth. Every civilization inherits more than buildings and machines. It also inherits ideas. Long before humanity possessed rockets powerful enough to leave Earth, a handful of thinkers were already asking questions that seemed impossibly distant from the world around them. They lived in different countries, spoke different languages, and worked under very different circumstances. Yet they shared one remarkable habit. They looked at the night sky and refused to believe that humanity's future would end on a single planet. The story begins in the late 19th century with Konstantin Tsiolkovsky. Living in relative isolation far from the great industrial centres of Europe, he imagined something extraordinary. Rockets, he argued, were not merely military devices or scientific curiosities. They could become the bridge between worlds. At a time when powered flight itself had not yet been achieved, he began calculating how spacecraft might escape Earth's gravity. His ideas appeared almost fantastical to many of his contemporaries, yet they introduced a profound shift in perspective. Space was no longer only something to observe, it became somewhere humanity might one day travel. One of his most enduring observations remains remarkably relevant centuries later. Earth, he suggested, is the cradle of humanity, but no one remains in the cradle forever. It was a simple sentence, yet it quietly challenged thousands of years of human history. For the first time, remaining on a single planet could be viewed not as destiny but as a temporary stage in civilization's development. A generation later, another visionary began transforming theory into engineering. Robert H. Goddard spent much of his career conducting experiments that many observers dismissed as impractical. His rockets were small, fragile, and often misunderstood. Newspapers occasionally mocked his belief that rocket propulsion might someday function in the vacuum of space. History would prove otherwise. Goddard approached the problem differently from philosophers. He wanted equations, experiments, and measurable progress. Every successful launch demonstrated that controlled rocket flight could gradually evolve from laboratory curiosity into practical technology. His work reminded future generations that extraordinary achievements rarely begin with extraordinary machines. They begin with small demonstrations that slowly accumulate into revolutions. By the middle of the 20th century, another name entered the story. Wernher von Braun imagined spacecraft on a scale unlike anything previously attempted. His published concepts included rotating habitats, capable of producing artificial gravity, enormous orbital construction facilities, and expeditions reaching far beyond Earth. Many of his illustrations appeared almost cinematic, yet they encouraged engineers to think beyond individual rockets and toward complete spacefaring systems. For the first time, people were not merely discussing how to leave Earth, they were discussing how to live away from it. That distinction would eventually become essential. Leaving Earth requires propulsion. Living beyond Earth requires civilization. Meanwhile, another thinker expanded the conversation even further. Freeman Dyson possessed an unusual ability to combine rigorous science with bold imagination. Rather than asking only how fast a spacecraft might be built, he explored what future civilizations could accomplish if they learned to manage energy on planetary or even stellar scales. His work encouraged scientists to measure progress not merely by machines, but by the capabilities of entire civilizations. This broader perspective quietly influenced generations of researchers. Instead of designing isolated spacecraft, they began imagining self-sustaining societies capable of surviving independently for centuries. Elsewhere, astronomers were asking a different but equally important question. Where should humanity go? Throughout the 20th century, increasingly powerful telescopes transformed tiny points of light into recognizable planetary systems. Researchers gradually discovered that planets were not rare exceptions. They appeared to be common throughout the galaxy. Every improvement in observational technology revealed additional worlds orbiting distant stars. The universe suddenly seemed far less empty. Yet discovering planets did not automatically make them reachable. That realization inspired another remarkable project. During the 1970s, members of the British Interplanetary Society began studying an ambitious concept known as Project Daedalus. Unlike speculative fiction, this effort attempted to design an interstellar vehicle using technologies considered plausible within known physics. The proposed spacecraft would be enormous, assembled in space, and powered by fusion reactions capable of sustaining extraordinary velocities. The design was breathtaking. It was also humbling. Even with optimistic assumptions, the journey to another nearby star would still require decades. The project demonstrated something profoundly important. Interstellar travel might not violate the laws of physics. It simply demanded engineering on a scale humanity had never achieved. Another concept proved even more dramatic. Project Orion proposed propelling massive spacecraft through carefully controlled nuclear explosions, occurring behind a reinforced pusher plate. The idea promised enormous performance compared with conventional rockets. Engineers calculated that such vessels might transport unprecedented payloads throughout the solar system, and perhaps even beyond. Technically, the concept possessed surprising merit. Politically, it faced overwhelming obstacles. The same technology capable of launching starships relied upon methods the world increasingly wished to leave behind during the nuclear age. History offered another lesson. Not every technically possible solution becomes socially acceptable. As future generations reviewed these early efforts, they noticed a common pattern. Every visionary solved one part of the puzzle, one advanced propulsion, another expanded engineering, another redefined civilization, another broadened humanity's perspective. None solved the entire problem alone. Perhaps that was never the point. Progress across centuries rarely depends upon a single genius providing every answer. More often it resembles a relay race in which each generation carries an idea a little farther before passing it onward. The people living aboard the generation ship understood this better than anyone. Their entire civilization existed because countless individuals separated by decades and continents had contributed pieces of a dream they would never personally witness. Yet these pioneers left another unanswered question. Imagining interstellar civilization was one thing. Testing whether human beings could actually endure life away from Earth was something else entirely. That experiment would not begin among the stars. It would begin much closer to home. Before humanity could seriously consider sending a civilization across interstellar space, it first had to answer a much simpler question. Could people remain healthy away from Earth for more than a few days? In the earliest years of spaceflight, no one knew the answer. Every launch was an experiment not only in engineering but in human endurance. The first astronauts carried with them a quiet uncertainty. They were venturing into an environment no member of their species had ever inhabited before. The earliest missions were astonishingly brief by modern standards. Hours became days. Days gradually became weeks. Each successful flight extended the boundary of what seemed possible. Engineers learned how to recycle small amounts of water. Physicians studied the effects of weightlessness on muscles and bones. Psychologists observed how isolation altered mood concentration and decision-making. Every mission returned with something more valuable than hardware. It returned with knowledge. As spacecraft became larger, another lesson emerged. Human beings could adapt to environments that initially appeared impossible. Life in orbit demanded new routines. Sleeping, eating, exercising, and even simple tasks such as drinking water required unfamiliar techniques. Yet after an adjustment period, astronauts developed rhythms that transformed the extraordinary into the ordinary. This ability to normalize unfamiliar environments would later become one of the strongest arguments in favor of generation ships. People are remarkably adaptable. That adaptability reached a new level with the construction of the International Space Station. Unlike earlier spacecraft, it was never intended for a single short mission. It became a continuously inhabited outpost where crews from many nations learned to live and work together for months at a time. Viewed from Earth, the station appeared tiny. Viewed from history, it represented something much larger. For the first time, humanity maintained a permanent community beyond the surface of its home planet. The station revealed countless practical lessons. Air recycling systems became increasingly reliable. Water purification reached levels of efficiency unimaginable during the earlier space missions. Medical monitoring grew more sophisticated. Engineers learned how to repair complex equipment in orbit rather than simply replacing it after landing. Perhaps even more importantly, astronauts demonstrated that international cooperation could flourish in one of the most demanding environments ever created. National boundaries mattered less inside a spacecraft. Competence, trust, and shared purpose mattered more. Yet the International Space Station also exposed important limitations. Crews still depended upon regular cargo missions. Fresh food arrived from Earth. Replacement equipment arrived from Earth. Medical emergencies could still be addressed by returning home. The station represented an extraordinary achievement, but it remained connected to civilization below. A true interstellar vessel would possess no such connection. Recognizing this difference, researchers began designing experiments that removed as many external supports as possible. On Earth, volunteers agreed to spend months inside sealed habitats simulating the isolation of deep space. They experienced communication delays, limited resources, repetitive surroundings, and prolonged separation from family and friends. Some experiments took place beneath deserts. Others occurred inside remote polar environments. Each attempted to answer the same fundamental question: how do people behave when there is nowhere else to go? The results proved both encouraging and sobering. Most participants adapted remarkably well. They developed routines, they formed friendships, they solved technical problems creatively. They learned to share responsibility under demanding conditions. At the same time, researchers discovered that seemingly minor disagreements could grow unexpectedly significant when escape was impossible. Small misunderstandings lingered longer. Personality differences became more noticeable. Leadership styles that work during short missions sometimes proved less effective over extended periods. Isolation amplified human nature. It did not replace it. Scientists studying these experiments reached an important conclusion. Technology could create a survivable environment. Only culture could create a livable one. The distinction mattered enormously. A habitat might provide breathable air, nutritious food, and reliable power. Yet if its inhabitants lost trust in one another, even perfect engineering could not guarantee success. The findings influenced every aspect of later Starship design. Living quarters were planned to maximize both privacy and community. Public gardens became psychological resources as valuable as ecological ones. Schools, theatres, sports facilities, libraries, and places for quiet reflection all became recognized as essential infrastructure rather than optional luxuries. Human well-being depended upon more than physical survival. It depended upon meaning. Another unexpected lesson emerged from these early experiments. People consistently performed better when they believed their work contributed to a larger purpose. Routine maintenance became more satisfying when connected to the survival of the entire mission. Scientific research felt more valuable when participants understood its long-term significance. Shared purpose reduced the emotional burden of isolation. The implication for an interstellar civilization was profound. Future generations would require more than technical education. They would need stories explaining why their civilization existed. Not myths disconnected from reality. Not propaganda, but an honest understanding of the sacrifices that made their world possible. Looking back, historians aboard the Starship came to appreciate these early experiments with new respect. What once appeared to be modest orbital missions or isolated research stations were in truth humanity's first rehearsals for life between the stars. They revealed that survival required a delicate balance. Engineering sustained the habitat, biology sustained the body, community sustained the people, purpose sustained the future, and yet despite all these lessons, one challenge remained almost entirely unsolved. Every experiment had lasted months or years. The journey ahead demanded centuries. The question was no longer whether humans could survive in space. It was whether an entire civilization could continue learning, adapting, and reinventing itself long after every founder had become part of history. By the 9th century of the voyage, the original launch date exists only in history books. No living person has seen Earth. No voice recorded by the founders remains familiar in everyday conversation. The civilization aboard the ship has entered a remarkable stage of maturity. It no longer survives because of its ancestors' preparations alone. It survives because each generation has learned how to prepare the next. That realization changes the meaning of progress. On Earth, technological progress is often measured by invention. Faster computers replace slower ones. New materials outperform older designs. Medical discoveries extend life expectancy. Advancement is visible because change happens rapidly. A generation ship measures progress differently. Its greatest achievement is continuity. Walk through the Central Academy where children of every age study beneath enormous glass domes filled with carefully cultivated trees. The classrooms contain advanced scientific equipment far beyond anything imagined by the ship's founders. Yet beside every laboratory stands something equally important, an archive. Every experiment, every engineering modification, every ecological adjustment, Every political reform, every unexpected failure, every successful recovery, all preserved with extraordinary care. Knowledge has become the civilization's most valuable natural resource. Unlike metals or fuel, it grows stronger when shared. Historians often describe writing as humanity's greatest invention because it allowed information to survive the death of individuals. The Starship expands that principle further. It transforms memory into infrastructure. Forgetting is treated with the same seriousness as mechanical failure because forgotten knowledge cannot protect future generations. This philosophy shapes every profession. Engineers spend nearly as much time documenting repairs as performing them. Doctors preserve detailed records of rare illnesses so descendants will recognize them immediately if they ever return. Farmers record subtle changes in crop behavior across centuries of cultivation. Teachers continuously revise educational methods while preserving the reasoning behind earlier approaches. Nothing important exists only inside one person's mind. The civilization has learned that individual brilliance is fragile. Shared knowledge is resilient. Meanwhile, another transformation unfolds almost unnoticed. Artificial intelligence, once little more than a collection of specialized software systems, has gradually become woven into nearly every aspect of daily life. It schedules maintenance before failures occur. It monitors ecological balance across millions of living organisms. It assists physicians by recognizing patterns too subtle for any individual researcher to detect. It translates historical records written centuries apart into language every generation can understand. Yet the people aboard remain careful. History has taught them that dependence without understanding creates vulnerability. Every citizen learns not only how to use these systems, but also the principles behind them. Human expertise remains essential because no civilization can safely surrender complete responsibility for its own survival. The relationship between humans and intelligent machines evolves into something resembling partnership rather than replacement. Artificial intelligence becomes the ship's longer-serving librarian, its most patient engineer, its most consistent historian, but never its ruler. That distinction is deliberate. Centuries earlier, philosophers debated whether increasingly capable machines should make important decisions for humanity. The civilization aboard the ship eventually reached a different conclusion. Machines excel at analysis. Humans remain responsible for values. A computer can estimate the consequences of reducing agricultural production. Only people can decide whether those consequences are acceptable. An intelligent system can recommend optimal resource allocation. Only society can determine what kind of future it wishes to build. This balance proves remarkably stable. Technology supports civilization. Civilization guides technology. Neither dominates the other. As the centuries pass, another unexpected advantage begins emerging from the ship's long isolation. Innovation accelerates. Without easy access to outside resources, every problem encourages creative thinking. Materials are reused in ways never imagined by their original designers. Biological systems inspire new manufacturing techniques. Medical advances improve ecological management, while ecological discoveries influence engineering. Disciplines that once seemed unrelated gradually merge. The civilization becomes deeply interdisciplinary because survival rewards cooperation across every field of knowledge. One invention leads unexpectedly to another. A more efficient recycling process reduces energy demand. The saved energy powers better manufacturing systems. Improved manufacturing enables stronger shielding. Stronger shielding extends the lifespan of observatories. Better observatories reveal new information about the destination. Progress forms an interconnected web rather than a straight line. Looking outward, astronomers notice another profound change. The destination star has become unmistakably brighter. Its planets now complete visible orbits through generations of observation. Seasonal changes can be estimated. Polar ice appears to expand and retreat. Vast cloud systems drift across distant atmospheres. The destination is no longer theoretical. It is becoming familiar. For children growing up aboard the ship, these worlds occupy the same place in imagination that Mars and Jupiter once occupied for people on Earth. They are places, not abstractions. This emotional shift quietly transforms education. Students no longer ask whether humanity will someday reach another star. They ask what careers will be needed after arrival. Planetary geology, atmospheric science, ecological surveying, settlement engineering. The future is acquiring practical detail. Still, one final uncertainty remains. No telescope, however advanced, can reveal everything. The ship continues approaching with patience measured in generations, knowing that the most important discoveries will only occur after arrival. And with every passing decade, one realization grows increasingly clear. The success of the mission will not depend upon whether the engines continue functioning. It will depend upon whether a civilization has become wise enough to step onto another world without repeating the mistakes it once made on its own. The journey is no longer teaching humanity only how to survive among the stars. It is teaching humanity how to deserve them. Nearly 1,000 years have passed since the Starship departed Earth. During that time, every prediction made by its original designers has been tested by reality. Some proved remarkably accurate. Others quietly failed and were replaced by better ideas. The vessel itself has become a record of continuous adaptation, shaped not by one generation of engineers, but by hundreds. Perhaps that is the greatest surprise of the voyage. The founders believed they were designing a spacecraft. Instead, they designed a civilization capable of redesigning itself. Walk through one of the oldest engineering districts, deep beneath the residential habitats behind layers of machinery that have operated for centuries. Enormous manufacturing halls continue working without interruption. Robotic systems move silently between fabrication chambers. Sheets of advanced materials emerge from automated production lines. Precision tools construct replacement parts for other tools, which in turn build new machines still more capable than those that came before. The factory no longer resembles the one launched from Earth. Almost every process has evolved. Some improvements were carefully planned. Others emerged from necessity. When an unexpected failure occurred centuries earlier, engineers developed a better solution. That solution became standard practice. Future generations refined it again. Over hundreds of years, countless small innovations accumulated into an industrial system far beyond its original design. The ship has learned. Not as a conscious organism, but as a civilization preserving successful ideas while abandoning unsuccessful ones. This ability to accumulate experience changes the meaning of maintenance. Replacing a damaged component is no longer enough. Every repair becomes an opportunity for improvement. A stronger alloy replaces an older material. A simpler mechanism replaces unnecessary complexity. A more efficient design reduces future maintenance requirements. Gradually, the vessel grows more reliable, not because it avoids failure, but because every failure contributes to future resilience. Historians notice that this mirrors one of humanity's oldest patterns. Cities recovering from earthquakes often rebuild with stronger foundations. Flood defenses improve after devastating storms. Medical knowledge advances through studying disease rather than avoiding it entirely. Civilization progresses because memory transforms hardship into wisdom. The Starship applies the same principle continuously. Engineers eventually describe the vessel using an unusual phrase. It is self-improving, not because machines redesign themselves independently, because each generation leaves behind better systems than it inherited. This philosophy spreads far beyond engineering. Education evolves through constant refinement. Agriculture becomes more productive with each century of ecological observation. Medical treatments improve as biological understanding deepens. Even government adapts, gradually preserving institutions that encourage stability while replacing those that no longer serve the needs of the community. The civilization has discovered that permanence does not require resisting change. It requires guiding change carefully. Meanwhile, artificial intelligence reaches another stage of development. Instead of merely assisting human experts, intelligent systems begin preserving entire chains of reasoning behind important decisions. Future engineers no longer read only technical manuals describing what previous generations built. They also understand why those choices were made. Historical context becomes searchable. Design philosophy becomes teachable. Institutional memory, once vulnerable to gradual loss, becomes remarkably durable. The result is profound. The civilization no longer depends upon a few exceptional individuals remembering everything. Its collective experience becomes available to every citizen willing to learn. Knowledge becomes democratic. This transformation influences scientific research as well. Researchers separated by centuries effectively collaborate through detailed records, simulations, and continuously evolving models. A hypothesis proposed hundreds of years earlier may finally receive confirmation because descendants possess instruments unimaginable to the original investigator. Time itself becomes a scientific partner. The voyage rewards patience in ways impossible on Earth. Astronomers tracking distant stellar motion across 9 centuries possess data unavailable to any planetary observatory. Ecologists studying enclosed ecosystems observe evolutionary changes unfolding generation after generation. Physicians examine long-term patterns of human health extending far beyond ordinary medical history. The civilization becomes uniquely qualified to understand slow processes. It has lived among them. Outside the ship, the destination system now fills telescopes with extraordinary detail. Several planets have confirmed atmospheres. One moon appears to possess a hidden ocean beneath layers of ice. Magnetic fields interact with stellar winds in graceful patterns visible across millions of kilometers. Seasonal cycles repeat predictably through decades of observation. The destination feels close. Not geographically, emotionally. For the first time, living citizens genuinely expect that their grandchildren or perhaps their great-grandchildren may witness arrival. The psychological effect is immediate. Construction begins on equipment that will only become useful after entering the new system. Planetary exploration vehicles are assembled. Survey instruments undergo repeated testing. Small robotic probes wait patiently inside storage bays where they have remained for generations, receiving quiet upgrades every few decades. The mission is entering a new phase. Preparation is no longer theoretical. It is practical. Yet as excitement grows, senior historians offer a gentle reminder. Arrival does not end the journey. It transforms it. Landing on another world will create challenges unlike those encountered during interstellar travel. Gravity weather, unfamiliar geology, and unknown biological conditions will replace the controlled environment of the ship. Humanity has spent nearly a millennium learning how to survive inside one carefully balanced artificial world. Soon it may need to learn how to live within a natural one again. The irony is striking. The civilization that once struggled to escape dependence upon Earth must now rediscover how to build a relationship with another planet. This time, however, it carries 1,000 years of hard-earned wisdom. It understands ecosystems. It understands resilience. It understands the value of patience. Most importantly, it understands that survival has never depended solely upon technology. It has always depended upon the character of the civilization using it. And with that realization, humanity stands on the threshold of the greatest breakthrough in the entire voyage. For nearly a millennium, the question has been how a starship could survive deep space. Now at last the answer begins to emerge, not through stronger engines, not through larger reactors, but through something far more remarkable, a civilization that learned how to renew itself without ever losing sight of the stars. The breakthrough did not arrive with a single invention. There was no moment when an engineer pressed a button and solved the problem of surviving deep space. No revolutionary engine suddenly erased the centuries separating one star from another. No miraculous material resisted time forever. Instead, the solution emerged so gradually that several generations failed to recognize it while it was happening. The Starship had stopped behaving like a machine. It had begun behaving like a living civilization. This distinction changed everything. For centuries, the founders believed they were building a vessel capable of enduring the universe. By the time the descendants reviewed 1,000 years of history, they understood something very different. A starship cannot survive because it is strong enough to resist change. It survives because it changes continuously without losing its identity. Walk once more through the oldest sections of the ship. The original structural framework still exists in a few carefully preserved chambers, protected almost as historical monuments. Visitors move quietly through these corridors, observing materials fabricated nearly a millennium earlier. They're surprised by how ordinary they appear. The metals are thicker than modern designs. The electronics are larger. Maintenance access is less efficient than in newer districts. Nothing about them suggests perfection. Yet without these humble beginnings, the civilization surrounding them would never have existed. Leaving the museum, visitors enter the active engineering complex. The contrast is extraordinary. Manufacturing systems now operate with almost complete autonomy. Microscopic sensors continuously inspect every major structure, detecting weaknesses long before human eyes could notice them. Swarms of maintenance robots travel silently through narrow service tunnels, replacing worn components before they become dangerous. Artificial intelligence predicts failures decades in advance by comparing current conditions with centuries of historical records. The ship is no longer waiting for things to break. It is preventing failure before it begins. This is the breakthrough the founders never fully imagined. Maintenance has become prediction. Prediction has become adaptation. Adaptation has become survival. The same philosophy extends into every layer of civilization. Agricultural habitats no longer respond only to poor harvests. They continuously adjust soil chemistry, lighting, and water circulation based on millions of environmental measurements collected every hour. Medical systems identify subtle biological changes years before symptoms appear. Educational programs evolve alongside new scientific discoveries, ensuring that every generation inherits knowledge suited to its own future rather than its ancestors' past. Nothing remains static. Everything remains connected. Engineers eventually describe the entire vessel using a phrase borrowed from biology. It is a self-healing system. Just as the human body constantly replaces damaged cells, the ship constantly renews itself. Individual components fail every day. Pipes wear out. Circuits degrade. Bearings lose precision. None of these failures threatens the mission because replacement has become an ordinary rhythm of life rather than an emergency. The civilization has accepted an unexpected truth. Immortality doesn't belong to individual parts. It belongs to the system that continually replaces them. This realization changes how historians interpret the voyage. Earlier generations celebrated the launch as the defining achievement. Modern scholars respectfully disagree. Launching the ship was remarkable. Keeping it alive for 1,000 years was vastly more remarkable. The founders built possibility. Their descendants built continuity. Outside the destination system now dominates astronomical observation. Its planets are no longer faint mathematical abstractions. Continents can be estimated. Massive storm systems drift across distant atmospheres. Polar regions brighten and darken with changing seasons. The civilization has spent centuries studying worlds it has not yet touched, learning patience that earlier explorers on Earth rarely possessed. That patience becomes another form of technology. Rushing no longer offers advantage. Understanding does. Meanwhile, preparations for arrival continue at an accelerating pace. Exploration vehicles undergo final redesigns based upon the latest planetary observations. Habitat modules intended for surface deployment are tested repeatedly inside enormous environmental simulation chambers. Scientific instruments capable of detecting unfamiliar forms of chemistry receive their last refinements after generations of development. Every department aboard the ship feels the approach of a new era, yet no one speaks of conquest. That language disappeared centuries earlier. Instead, the mission is described using quieter words: observation, learning, stewardship, coexistence. The voyage has transformed humanity's ambitions as profoundly as it has transformed its technology. The founders dreamed of reaching another star. Their descendants dream of arriving without causing irreversible harm. Looking back across the entire mission, the pattern becomes unmistakable. The first obstacle was propulsion. The second was time. Then came machinery. Then biology. Then psychology. Then society. Every apparent solution uncovered a deeper challenge until the civilization finally recognized the underlying principle connecting them all. A real starship does not survive because any individual technology is perfect. It survives because every generation improves every technology while preserving the values that make improvement possible. Knowledge remains open. Responsibility remains shared. Curiosity remains alive. No reactor can manufacture those qualities. No computer can guarantee them. They belong only to civilization itself. And as the destination star slowly expands from a brilliant point into a true sun awaiting the first human visitors, one final realization quietly settles over the ship. The greatest breakthrough was never hidden inside the engines. It was hidden inside humanity's ability to become a society that could think not in years but in centuries, and not in centuries but across the lifetime of an entire interstellar journey. The ship is finally ready. The deeper question is whether humanity is as well. As the destination star grows brighter in the ship's sky, another realization quietly takes hold. The vessel has survived for more than 1,000 years, not because it escaped the laws of nature, but because it learned to live within them. Every system aboard has accepted a simple truth. Nothing lasts forever. Everything must be renewed. That philosophy now extends beyond machines and into the civilization itself. Walk through the great central archive, one of the largest structures ever built inside the ship. It is neither a library nor a computer center in the traditional sense. It is something far more unusual. Every scientific paper, every engineering blueprint, every ecological survey, every legal decision, every piece of music, every work of literature, and every recorded conversation considered historically significant has been preserved here. The archive contains more than information. It contains memory. A child entering its halls can study the words of the founders almost as easily as yesterday's research report. Centuries no longer separate generations as completely as they once did. Technology has compressed history into something that can be explored in an afternoon. Yet memory alone cannot guide a civilization. Someone must decide which lessons still matter. Artificial intelligence has gradually assumed an unexpected responsibility. Rather than replacing historians, it has become their companion. It compares events separated by hundreds of years, identifies recurring patterns, and reminds researchers when present-day problems resemble forgotten crises from earlier centuries. An engineer facing a structural failure receives not only technical specifications, but also accounts of similar failures occurring 400 years earlier. A physician diagnosing a rare illness gains access to every known treatment ever attempted aboard the ship. A political leader debating resource allocation can examine centuries of previous decisions and their consequences. The artificial intelligence does not make the decision. It expands human memory. This distinction becomes one of the civilization's greatest strengths. History is no longer trapped inside dusty archives. It actively participates in everyday life. Over time, citizens begin referring to the system almost affectionately. Not as a ruler, but as the oldest member of the community. It remembers events no living person experienced. It preserves forgotten languages. It safeguards cultural traditions that might otherwise disappear beneath the constant pressure of change. Ironically, one of the most advanced technologies aboard the vessel serves one of humanity's oldest needs: remembering. The relationship between people and intelligent machines grows increasingly sophisticated. Machines excel at detecting patterns hidden within enormous collections of data. Humans excel at assigning meaning to those patterns. Together they form something neither could achieve alone. This partnership transforms scientific discovery. Astronomers analyze centuries of observations with extraordinary precision. Tiny variations in stellar brightness reveal details that would have remained invisible during shorter missions. Ecologists study evolutionary changes occurring across hundreds of generations of plants and microorganisms. Engineers identify maintenance cycles so subtle that they unfold over decades rather than years. The voyage itself becomes an unparalleled scientific laboratory. Time, once viewed as the enemy, has become one of civilization's greatest research tools. Meanwhile, preparations for entering the destination system accelerate. The first robotic probes are awakened from centuries of storage. Their designs have been continuously updated throughout the voyage until very little of the original hardware remains. They represent 1,000 years of accumulated engineering knowledge, waiting patiently for a single purpose: to go first. No one wishes to repeat mistakes made during earlier eras of exploration on Earth. Before humans approach any planet, autonomous probes will map its surface, analyze its atmosphere, measure radiation levels, search for signs of existing life, and identify regions where careful scientific study can begin without unnecessary disruption. Patience once again defines the mission. The civilization has waited a millennium. It can wait a little longer. Young students often visit the probe assembly halls. They watch technicians performing final inspections, while teachers explain that these machines may become the first human creations ever to touch another planetary system. The children listen with quiet fascination. Unlike their distant ancestors, they do not dream primarily of heroic explorers planting flags beneath alien skies. They dream of understanding. The heroes are scientists, engineers, physicians, ecologists, historians, and teachers. The voyage has reshaped the culture's definition of greatness. Knowledge has become more admired than conquest. Cooperation more admired than competition. Stewardship more admired than ownership. Looking back across the previous 1,000 years, historians recognize how extraordinary this transformation truly is. The ship did not simply preserve humanity. It refined it. Every crisis encouraged greater resilience. Every failure improved future designs. Every generation inherited wisdom accumulated by countless predecessors. Civilization itself became the mission's most successful technology. And yet one final question remains unanswered. Suppose the probes confirm that one of the distant planets is suitable for settlement. Suppose its atmosphere can support carefully managed human communities. Suppose no complex native life exists to endanger or be endangered by a rival. What happens next? For over 1,000 years, humanity has learned to live inside an artificial world sustained entirely by its own effort. Stepping onto a natural world again will not merely change where people live, it will change how they understand themselves. The greatest challenge of the voyage may no longer be surviving deep space. It may be remembering everything deep space has taught them once they finally leave it behind. The first images arrive without ceremony. There is no cheering crowd waiting beneath a launch tower. No television broadcast reaching billions of people across Earth. The only witnesses are the descendants of those who began the journey more than 1,000 years earlier. Inside the ship's central observatory, thousands gather in respectful silence as the first autonomous probe completes its long descent through the atmosphere of a distant world. Clouds drift beneath its cameras. Mountain ranges emerge along the horizon. Rivers carve winding paths across broad valleys. For the first time in human history, another planetary landscape fills the screen not through imagination, but through direct observation. The room remains quiet, not because the moment lacks significance, because its significance is almost too large for words. The probe continues descending. Winds buffet its protective shell before parachutes deploy. Dust rises beneath retro rockets. Instruments begin recording atmospheric chemistry, gravity, temperature, and radiation with extraordinary precision. Then almost imperceptibly the motion stops. Humanity has reached another world, not in person, but undeniably. The announcement spreads throughout the ship within minutes. Schools pause their lessons. Factories temporarily suspend routine operations. Families gather inside public squares where enormous displays replay the landing from every available camera angle. For many citizens, it feels less like the beginning of a new chapter than the conclusion of an ancient promise. Yet the scientists remain cautious. Landing is not understanding. The first weeks are devoted entirely to observation. Robotic laboratories analyze soil composition. Small aerial drones map nearby terrain. Sensitive instruments search for organic molecules, microbial activity, and chemical processes unlike any known on Earth. Every measurement is repeated. Every conclusion is independently verified. The civilization has learned that patience protects both science and wisdom. The results gradually accumulate. The atmosphere proves stable enough to support carefully designed habitats. Water exists in abundance. Mineral resources appear plentiful. Most importantly, no evidence of complex native organisms emerges within the initial survey region. Simple chemistry fills the environment. Life, if it exists elsewhere on the planet, has not yet revealed itself. The news inspires cautious optimism. Preparations begin for humanity's first landing. The decision is unlike any previous expedition in history. When ancient explorers sailed across oceans, they often departed knowing that rescue remained theoretically possible. Even early astronauts could hope for emergency assistance from Earth. Here, there is no higher authority waiting beyond the horizon. The people making this decision represent the only human civilization within light years. Responsibility belongs entirely to them. Committees of scientists, historians, engineers, physicians, and philosophers spend months reviewing every available observation. The discussion is remarkably broad. Where should the first settlement stand? How much land should remain permanently protected? Which technologies should be introduced immediately? Which should wait until the environment is better understood? The civilization has spent centuries preparing for this moment. It refuses to hurry now. Eventually consensus emerges. The first human presence will be intentionally small. Temporary habitats rather than permanent cities. Research before expansion. Understanding before transformation. The philosophy reflects everything the voyagers taught. Survival comes from restraint as often as ambition. Construction begins aboard the ship. Landing craft preserved and continuously improved throughout generations undergo final inspection. Environmental suits receive their last upgrades. Scientific instruments are calibrated one final time. Families watch with quiet pride as the first crews prepare. No one aboard considers them conquerors. They are caretakers carrying the accumulated experience of 1,000 years. On the evening before departure, the crew gathers inside one of the oldest gardens aboard the ship. Ancient trees planted centuries earlier spread their branches beneath artificial sunlight. Some were grown from seeds that ultimately trace their ancestry back to forests on Earth. The symbolism is unmistakable. Life that once crossed interstellar space now prepares to place new roots beneath another sun. The following morning, the landing craft departs. Its engines burn only briefly before the immense planet fills every window. As the vessel descends, clouds sweep past the hull. Mountain peaks emerge through morning light. Vast plains stretch toward distant horizons untouched by human footsteps. Every person aboard understands that history is changing forever. Then the landing legs meet the ground. For several seconds nothing happens. The engines fall silent. Dust slowly settles. The hatch remains closed while external sensors complete their final safety checks. Inside, the crew waits. Outside lies another world. Finally the hatch opens. A single figure steps carefully onto unfamiliar soil. There are no speeches, no flags, no declarations of ownership, only quiet observation. The explorer kneels, touches the ground gently and looks toward the horizon. The moment lasts only seconds, yet it represents more than the arrival of one expedition. It represents the arrival of an entire civilization that survived long enough to fulfill a promise made more than a millennium earlier. Back aboard the ship, millions watch in silence. Many realize something unexpected. The greatest achievement was never reaching this planet. The greatest achievement was becoming the kind of civilization capable of reaching it without forgetting humility. Still another question quietly waits beyond the celebration. If humanity can now live beneath two different suns, what does the word home truly mean? The first settlement grows slowly exactly as its planners intended. No sprawling cities appear across the landscape. No vast industrial complexes transform the horizon. Instead, a handful of carefully designed habitats rise beside one another, like islands of human experience surrounded by an ancient, unfamiliar world. Every structure is monitored continuously. Every interaction with the environment is recorded. Every decision is treated as part of an experiment that may shape the future of civilization for thousands of years. From orbit, the settlement is almost invisible. That is deliberate. The people who crossed interstellar space understand something their ancestors often struggle to accept. A new world is not an empty canvas waiting for humanity to paint its ambitions across the surface. It possesses its own history written over billions of years by geology, climate chemistry, and perhaps forms of life still hidden beyond current observation. The first settlers therefore become students before they become builders. Each morning begins with exploration. Teams travel only short distances from the habitat, collecting rock samples, studying weather patterns, and mapping ecosystems too subtle to recognize from orbit. Every evening they return, comparing observations with scientists still living aboard the Starship. The conversation between planet and ship never stops. The vessel that carried civilization across the stars remains suspended high above, orbiting quietly like a second moon. Supplies continue flowing downward. Research data flows upward. Although humanity has technically arrived, the journey is not yet over. The Starship still serves as the heart of civilization. Many people choose to remain aboard it. Some are elderly and have no desire to begin life again beneath open skies. Others devote themselves to operating the orbital laboratories that continue observing the entire planetary system. Children still attend schools inside the rotating habitats. Farms continue producing food. Manufacturing centers remain active. The ship has not become obsolete. It has become a partner. For the first time in history, humanity exists simultaneously as a planetary civilization and a spacefaring civilization. This balance proves remarkably stable. The surface settlement benefits from the ship's accumulated knowledge and industrial capacity. The ship benefits from discoveries made below. Geological samples reveal new materials useful for manufacturing. Atmospheric studies improve biological research. The relationship resembles that between an ancient city and the surrounding countryside, each supporting the other in different ways. Historians recognize the significance immediately. Human civilization has crossed an invisible threshold. For thousands of years, every branch of humanity depended ultimately upon a single planet. Now the relationship has changed forever. If disaster strikes one world, another remains. If one habitat suffers catastrophe, others preserve the knowledge, culture, and memory of the species. Redundancy, once an engineering principle, has become a civilizational principle. The implications stretch far beyond this single star system. Astronomers continue observing neighboring suns. Engineers begin discussing future expeditions. Young students grow up believing that traveling between stars, while still immensely difficult, belongs within the natural horizon of human possibility. The impossible has quietly become practical. Not easy, never routine, but conceivable. That transformation may be the voyage's greatest legacy. The first generation looked upward with hope. The current generation looks outward with responsibility. There is an important difference. Hope seeks opportunity. Responsibility considers consequences. As settlements slowly expand, planners preserve enormous protected regions untouched by development. Some valleys become permanent scientific reserves. Entire mountain ranges remain inaccessible except for carefully supervised research. The civilization remembers Earth's environmental history too well to repeat it carelessly. Progress is measured not only by what humanity builds, but also by what it chooses to leave unchanged. This philosophy gradually shapes law, education, and culture. Children learn that exploration and restraint are not opposites. They are partners. Scientists celebrate discoveries with the same enthusiasm whether they reveal resources for future settlements or reasons to avoid disturbing a fragile ecosystem. Knowledge remains more valuable than possession. Years become decades. The temporary habitats evolve into thriving communities connected by transportation systems, carefully integrated with the surrounding landscape. Agriculture expands cautiously. New observatories appear across remote plateaus. Universities establish research campuses studying the unique geology and atmosphere of the new world. Life continues. Ordinary life. People fall in love. Children are born beneath a different sun. Artists paint unfamiliar constellations. Musicians compose works inspired by winds that never blew across Earth. Human culture branches again. Looking back toward the orbiting starship, many settlers experience an unexpected emotion. Gratitude. That immense vessel no longer represents escape. It represents ancestry. Every beam, every corridor, every garden preserved a civilization long enough for this moment to exist. Without it, this world would have remained forever beyond human reach. Yet even now, the oldest philosophers caution against believing the story has reached its conclusion. Another generation will someday look toward even more distant stars. Another civilization will ask whether the journey should continue. The answer will depend upon lessons inherited from those who came before. Just as this voyage depended upon dreamers separated by centuries, future voyages will depend upon the wisdom earned here, because the universe remains unimaginably vast. One successful journey does not diminish that scale. It simply reminds humanity that the story is still being written. More than 1,000 years after the first engines carried humanity away from Earth, the question that began the journey has finally acquired an answer. How long could a real starship survive in deep space? Long enough. Not because its metal was indestructible, not because its computers never failed, not because its reactors produced limitless power. The ship survived because every generation accepted responsibility for a future it would never personally see. That realization becomes one of the founding principles of the new civilization. Schools on the planet teach children that the greatest invention carried across the stars was not a propulsion system or an artificial ecosystem. It was long-term thinking. Humanity learned to make decisions whose rewards belonged almost entirely to strangers living centuries later. History had offered hints of this lesson before. Ancient forests were planted by people who knew they would never sit beneath their mature branches. Cathedrals were begun by builders who understood that completion would belong to their grandchildren. Scientific discoveries often required generations of researchers, each contributing only a small part of the final understanding. The generation ship extended that pattern further than anyone had imagined. It transformed patience into the foundation of civilization. The people living beneath the new sun continue maintaining the Starship in orbit, even though many will never again set foot inside it. They preserve its oldest compartments exactly as previous generations preserved monuments on Earth. Visitors walk through narrow corridors where the founders once lived, reading handwritten journals, examining worn tools, and looking through observation windows that once framed the fading light of the solar system. The ship has become more than a machine. It has become humanity's memory. Children often ask why such care is given to preserving a vessel no longer required for survival. The answer is always the same, because civilizations that forget how they survived rarely survive again. The Starship reminds every generation that comfort was purchased through sacrifice. Every peaceful city beneath the new sky exists because countless people accepted hardship without expecting personal reward. Gratitude becomes a practical virtue rather than merely an emotional one. Meanwhile, philosophers begin asking questions that would have seemed impossible a millennium earlier. What defines humanity now? Is it biology, language, shared history, or is it something deeper? For thousands of years, human identity had been inseparable from Earth. Every religion, every nation, every language, and every culture emerged beneath the gravity of one planet. Now children are born who have never seen Earth and never expect to. Their memories begin beneath another constellation. Their first sunrise belongs to another world. Yet they still call themselves human. The continuity is remarkable. Across all the technological revolutions, political changes, biological adaptations, and cultural transformations of the voyage, one thread remained unbroken. The desire to understand. Curiosity survived every generation. That simple observation leads scholars to a profound conclusion. Perhaps civilization is not defined primarily by where it lives. Perhaps it is defined by the questions it continues asking. The first humans wondered what lay beyond the nearest hill. Later generations asked what existed beyond the ocean, then beyond the atmosphere, then beyond the solar system. The destination changed. The curiosity remained the same. Astronomers continue scanning the galaxy now from observatories positioned both on the planet and aboard the ancient ship. They identify additional planetary systems. Some appear even more promising than the one humanity now inhabits. Others reveal strange worlds unlike anything previously imagined. The universe refuses to become familiar. Every discovery expands the frontier instead of shrinking it. This endless expansion has an unexpected psychological effect. The civilization no longer thinks of exploration as a race with a finish line. It understands exploration as a permanent relationship with the cosmos. There will always be another question, another horizon, another mystery. The journey therefore never truly ends. It changes form. Parents teach their children that their ancestors once believed surviving deep space was the greatest challenge imaginable. History proved otherwise. The greater challenge was learning how to remain compassionate while wielding extraordinary technological power, learning patience in a universe that rewards haste with irreversible mistakes, learning humility beneath skies filled with billions of stars. Those lessons shape every institution. Scientific research proceeds carefully. New settlements expand gradually. Environmental stewardship becomes inseparable from economic planning. Even political disagreements unfold within a culture that remembers how fragile civilization once was. The memory of vulnerability becomes one of humanity's greatest strengths. Looking upward at night, people see not only their new sun, but also the faint glimmer of the orbiting generation ship crossing silently overhead. It appears almost insignificant against the vastness of space. Yet everyone understands what it represents. Proof that civilization can endure. Proof that hope can survive across centuries. Proof that history, when carefully preserved, can become a bridge reaching farther than any engine ever could. Still, one final question remains, not for scientists, not for engineers, but for humanity itself. If one star has become two and two may someday become many, what kind of civilization will eventually spread across the galaxy? The answer will not depend upon technology alone. It will depend upon whether future generations remember the quiet lessons learned during the longest journey their ancestors ever undertook. Tonight we began with what seemed like a question about a machine. How long could a real starship survive in deep space? After following this voyage across more than 1,000 years, the answer has become something far more profound. A starship can survive for centuries, perhaps even millennia, but only if it eventually stops being thought of as a machine. It must become a civilization. Look once more toward the night sky of this distant world. The ancient generation ship still circles high above its lights, moving slowly against unfamiliar constellations. Below, cities glow softly along river valleys that no human eye had ever seen when the voyage began. Forests planted by the first settlers now sway beneath an alien breeze. Children laugh beneath a different sun, never questioning that humanity belongs here just as earlier generations once believed humanity belonged only to Earth. To them this world is ordinary. History often works that way. The impossible becomes familiar. The extraordinary becomes routine. Every civilization eventually forgets how remarkable its own existence truly is. Yet the old ship remains in orbit as a quiet reminder. It remembers. Its oldest corridors still preserve the marks left by engineers who never imagined another sunrise beyond the solar system. Its archives still contain the voices of people who accepted a future they would never witness. Every repaired beam and every replaced circuit tells the same story. Nothing survived because it lasted forever. Everything survived because someone cared enough to renew it. That may be the deepest lesson of the entire journey. The universe does not reward permanence. Stars are born. Stars grow old. Stars eventually die. Galaxies collide. Planets change. Even the atoms inside our own bodies were forged inside ancient stars that disappeared billions of years before Earth existed. On a cosmic scale, change is not the exception. It is the rule. Human civilization succeeds only when it learns to participate in that change instead of resisting it. For thousands of years, people searched for permanence in monuments, empires, and technologies. Again and again, history demonstrated that none of these could endure by themselves. Stone erodes, steel corrodes, information disappears, political systems evolve. The voyage between the stars revealed something stronger than permanence: continuity. A civilization capable of teaching every generation how to care for the next becomes remarkably difficult to destroy. That principle reaches far beyond space travel. It applies equally to nations, families, scientific communities, and cultures. Every child inherits a world built by strangers. Every adult shapes a world they will never completely experience. The generation ship simply made that truth impossible to ignore. Standing beneath this new sky, humanity finally understands that exploration was never about escaping Earth. Earth was never a prison, it was a beginning. The purpose of leaving was not to abandon one world, but to ensure that the story begun there could continue wherever curiosity carried it. And curiosity has always been humanity's most renewable resource. Unlike fuel, it cannot be exhausted through use. Unlike metals, it does not become scarce. Every answer creates another question. Every discovery opens another horizon. Every generation inherits mysteries larger than the ones it solved. Perhaps that is why the universe feels so vast. Not because it is empty, but because it always contains more questions than answers. Somewhere beyond this planetary system, countless other stars continue shining through the darkness. Around many of them, unseen worlds complete silent orbits. Some may be barren. Some may possess oceans beneath frozen crusts. Some may already host forms of life entirely unrelated to Earth's ancient ancestry. Humanity does not know, and that ignorance is not a weakness. It is an invitation. One day, another civilization may gather inside another starship. Their vessel may be wiser than the first, built from technologies not yet imagined. They may study the records preserved by the pioneers who crossed the first great gulf between stars. They may smile at the simplicity of those ancient machines in much the same way modern engineers smile at the earliest rockets. Yet one lesson will remain unchanged. No engine will ever carry civilization farther than its willingness to cooperate. No reactor will ever generate more power than shared purpose. No artificial intelligence will ever replace wisdom. No destination will ever matter more than the character of the people who arrive there. The first interstellar voyage was never truly a story about reaching another sun. It was a story about becoming a civilization capable of surviving time itself. Perhaps that is the real measure of an advanced civilization. Not the size of its spacecraft, not the brilliance of its technology, not even the number of worlds it inhabits, but whether it can preserve compassion while expanding across the stars. Whether it can remain curious without becoming reckless, whether it can grow more powerful without forgetting how fragile life has always been, because the universe will never become smaller. Its distances will remain immense. Its mysteries will remain endless. Its silence will continue inviting questions that no generation can answer alone. And somewhere perhaps, millions of years from now, beneath another unfamiliar sky, someone may look upward, see a distant point of light and realize that it is not just another star. It is home. The story of humanity will not end there. Like the universe itself, it will simply continue.